From Datastax, this is the Distributed Data Show podcast. And hello, everybody. Welcome to our final episode of Graph Data and Code. I am David Jones-Gilardi, joined today by the thrilling, exciting, mind-blowing, phenomenal, spectacular, remarkable, sensational, awesome, awe-inspiring, and breathtaking Denise.
Oh, thanks, David.
Was that good? Did I just get all of those off? I was trying to not go for the bad ones that are on the list.
I appreciate it. I'm always curious where you're going to go at the beginning of these, but I absolutely love getting to work with you and doing these series every week. So thank you so much for doing this with me, because I'm sad this is our last show.
I know, it is the last one.
Yeah, but everyone who's been following the series has all of the tools that you need to get started with the majority of ways that people are using graph databases in production applications. So I'm glad that we've reached that point.
Yes.
And I'm looking forward to learning about what everyone else out there starts to build. So yeah, so that's, I guess we're kind of here to wrap it up today.
We're going to wrap it up today. And funny enough, last week you kind of warned me as something. I shouldn't even say anything, right? Maybe you forgot, but you warned me you're going to make me do things this week. And I haven't done any kind of preparation, right? Because I don't think you didn't give me homework. So I'm so curious to see what it is you're going to lay on me today.
Yeah.
We're going to wrap up with. I'm hoping I don't fail miserably in front of everybody. But
I don't think you will. Everyone here has all the tools, and you have all the tools you need to do the basics. So here's what I was thinking we would do.
Okay, what are we going to do?
So there's a lot of really exciting examples that we have jam-packed at the very end of the book for a series of way to pull all of this together that we're going to leave as an exercise for everyone listening. Okay. So what I wanted to do today was to introduce what that is. Like, what is the example that we're not doing on the live stream and we're handing over for everyone else? Okay. That's the first thing. And then I would like to look at that example in the notebook and go through just maybe one or two basic queries that apply the templates from the full series. So the templates are neighborhoods, trees, and paths.
Okay.
So we apply those three templates to the final example in chapter 10, 11, and 12.
Okay.
So those are going to be the query of, for this person, find everything around them that we've been doing this whole time. We probably do it almost every episode. And then there's also the query of start here and recursively keep walking until you hit an endpoint. And that's the tree query. And then the path query. Those are the three examples that we might get into today, at least point folks to where you can do them in chapter 10.
Okay.
And throughout the show, as we're doing those things, the last thing that the show is all about is an AMA. So we've got some examples, and I'm happy to give you guys a preview on where the end of the book goes and what kind of stuff you all can do on your own. But we're following all your questions here. I have the LinkedIn stream pulled up on my other monitor. I also have the YouTube stream on Datastax Developers pulled up.
Okay.
So glad to see some familiar faces showing up. Hello, it's good to see you all on our live stream again. So if you have a question, feel free to ask it, because today's the last episode. We want to get your questions.
That's right. This is the time. If you've been waiting all this time to ask a question to try to stump Denise, this is the time to stump Denise, right? The final episode.
And this is an easy thing to do, guys. Like, it is not difficult.
I don't know. So far, you've actually proved pretty resilient to stumping you. So,
well, that's it's helpful when I have a great partner like you, because we get time and we figure it out together. So that's what this is all about, right? Oh. But hey, what I do think would be useful is we're going to start off. So what we want to do is we want the chapters 10, 11, 12 are the chapters in the book that we are skipping doing like a full tour through.
Okay, right.
What they do is they lay out how Netflix does that recommendation pane that we've probably all been hitting on now that we're all at home, watching our streaming services more often.
Right.
It lays out exactly how to think about that from an analytics perspective and to do the analytics computation, and then how to translate that into a graph database query that can be done, in real time. So chapter 10 is more of like the analytics. Let's explore how to do recommendations for movies. And then chapter 12 is, well, let's show you how an application actually translates that really, really long process into a query that can be done in a few milliseconds so that you're serving it at like Netflix scale. So that's what's in 10, 11, and 12. But what it does is it cobbles all together the patterns that we've been learning, how to explore neighborhoods, how to do paths, or how to apply path distance to mean something. So it brings it all together to do what we call collaborative filtering. And so what I want to do is start with defining collaborative filtering.
Okay.
We're going to do that. And so for that, I think we need to share the Lucidchart link, the chapter 10,
Chapter 10?
Lucidchart link. Yeah.
Right,
so let's
drop this. Chapter 10.
Yeah. So we're gonna go through this material pretty fast, just so you all know where to go. And David has all of the admin privileges. Whenever I share links on our different chatting platforms, it eats my links. So.
Yeah. By the way, I just need to point out when we talked about the AMA, just so you know, Daniel Cuppets came on. AMA sounds good. Let me prepare some questions with
and Cedric just hopped on
Ready
there
as well. Evil.
You guys, this is not hard. You can totally stump me.
That's great.
Yeah, so I welcome it. Please ask questions. And I will quickly tell you when I don't know, because I'm not.
And Frank says it took me ages to find out what AMA is. It's not common usage in Europe. So to that point, an AMA is an Ask Me Anything for those who may not be familiar with that. So that's what we mean by if you have any questions or anything like that as we wrap up the material, and if you want to, pepper Denise with things,
or David,
or Denise with whatever, then you can ask anything. Yeah.
Cool. Yeah, so that'll be fun. We'll do that. And it looks like, David, I see the chapter 10 link on YouTube. I don't see it on LinkedIn.
I totally put it there. It's totally there.
Oh, there it is. Sorry.
Okay, good. It does take a second. Yeah, it does take a second to update sometimes. So.
Yeah, so the 3 things, an AMA throughout, so let your questions happen. And then the 2 items that Dave and I are going to walk through are going to be what happens at the end of the book so that you all can take it and go. And then we're gonna repeat some of the basic queries that we've done throughout this entire series, neighborhoods, trees, and paths, with the movie examples. So with that in mind, let's hop right in and let's take a look at figure 10.6 in that Lucidchart.
Let me share my screen. And you said 10.6, and guess what? I just happen to be on 10.6. I mean, go figure. How did that happen?
Did you have that set up?
How did that happen? I have no idea. I'm already zoomed in and everything. I don't know how that happened. All right, what do we have? What do we have going here?
Yeah. So for some of you who might be joining this live stream randomly at the end, or for those of you who've been following along, I highly recommend you grab the examples so that you are playing with the code. Because one of my favorite mentors told me, if you're not breaking something, you're not coding hard enough. So where you can go to get that, I don't know if you have that pulled up as well, but downloads.datastax.com. You want to download Datastax Desktop because when you download Datastax Desktop, there is a stack there called the Graphbook Examples. And when you fire up that stack, all you need to do is have Docker on your local machine. And here you go. David is showing you where to go to get Datastax Desktop. Download it, and then there you go. You can see in the interface that you can fire up the Graphbook stack, and that's going to create the database schema. It's going to load all of the data and get you ready just to hop into the Chapter 10 notebook and query along right with us. So it does all the work on the back end for you so that you can just start learning how to apply different graph database technologies to solve really cool problems. So that's what we have set up in the back end, and you are welcome to use these Lucidcharts. They're all of the book images that are in the Practitioner's Guide to Graph Data. So I think the link we just shared on LinkedIn and YouTube will drop you right into Chapter 10. We've shared. Can you share the link to all of them actually?
Oh yeah, of course.
If you need me to, I can get that for you. But
I think there is a share link in here. We did this last time.
Yep.
And I remember I have to do it properly. I'm just looking for the shared thing. I swear every time I do this, it moves. But
sorry. Sorry.
It's my fault. It's totally my fault. You guys are watching me like scramble around here, like, where'd it go?
And I can send it to you if you'd like me to get you the direct link, if that's going to be easier.
Yeah, that might be because I'm not finding it.
Okay. Which chat method should I send it to you?
Oh, any. Put it in Social Live is fine.
Okay, great. Yeah, I'll send that over to you. And this next link that you guys are going to get on the different, I just sent it in via Social Live.
Got it.
The next link that you guys are going to get is the link to all of the chapters of Lucidcharts. I have all of these images enumerated according to their position in the text. So if you all are wanting to follow along and just take a look at the color version of the images, I would highly recommend using this, because in the print version of the Practitioner's Guide to Graph Data, they're black and white. So these are much easier to follow than the print.
They're Noir.
Yeah.
Film Noir style.
yeah. This is much easier.
All right, that should be all dropped.
Awesome. Thanks, guys. And David, thank you so much for sharing all those links. So where we have been is we have taken a tour through a financial systems example, and we did neighborhoods, like, for this customer at my bank, tell me everything about them. Then we took a tour through hierarchies. We spent some time talking about the power grid in the United States and how to use queries that go up and down trees, or from parents to children, or children to parents, to predict tower failure scenarios for the power grid. And the example we just came from was finding paths throughout the open source Bitcoin OTC network, so that you can understand or start to make an inference about how much you trust somebody on a social network, according to how closely connected you are to that person. So those are the 3 examples we've done. And this last example that we are sending you all off to go do on your own is the movie recommendation example. And what you're looking at here on the chapter 6 or chapter 10 image is just a way to think about how movie recommendations work in a graph. When you're using this example, there are 2 popular movie sets that I merged together. It's the Movie Lens database, and the Movie Lens database gives you, I think, 20 million different movie ratings for their users.
Just a couple. Okay.
Just a couple. Yes, so when you're loading up the chapter 10 data, you have all of that there, so be careful, but have fun at the same time. Like, break something, see what query you run that totally kills all of your RAM, because that's some of the fun part about working with graph data. So it's all there. In addition to, we merged that with Kaggle's movie database. Okay. So there's 2 different movie database data sets that I merged together for you all. And in case you're curious, chapter 11 in the book takes a little bit of a side tour on how I did that merge, and then a full report out of the true positives, false negatives that we found in that merging process. So chapter 11 is kind of a side tour in entity resolution, how I merged those sets together, and when we did use a graph to inform the merging of those data sets. But the work of how to do collaborative filtering, the math side of it is chapter 10, and then the production side of the query that boils down to a neighborhood lookup is what we do in chapter 12.
Okay. So I got to ask, though, why is it called collaborative filtering? Is that something you were going to talk about?
That's a really great example. That's a really great question. And you might have stumped me right off the bat.
Early stump.
Yeah, honestly, David, I don't know. I cannot come up with a very good reason right now as to why this is called collaborative filtering. It's I know that collaborative filtering started as a really large, like, matrix-based operation, and what you're looking at here is how the graph community has adopted collaborative filtering to use a graph structure to do a recommendation. But I would love to know if anyone following along on this stream who's done recommendations for it has the origin story on why it's called collaborative filtering, because I don't know. Love it. I love it. Do you know, David? Have you, or I guess that's why you were asking.
Yeah. Daniel says Matthias came up with the term.
For real?
So Matthias came up with it. The question is what does it mean? What does it mean?
See, and now I really want to go ping Matthias and ask, because that is new. I did not know that. So thanks, Daniel. I will go ask Matthias, who is the co-author on this book, and never said anything to me during the 2 years that we were writing it, that he was the one who came up with the method. So I'm gonna have to go ask him about that. But so what we are talking about, though, we've said it a few times, collaborative filtering. Collaborative filtering is a way to take some input and to score and rank your options to come up with some type of recommendation, like the most likely recommendation, the second most likely recommendation. And the method on how that works is what we are calling collaborative filtering. And this example that we're looking at at a picture, it works for some, not everybody. But in my head, David, we've been talking this whole time during this series about just kind of explaining how Denise sees some of these graph problems.
Right.
when I think of collaborative filtering in a graph, I see this in my head. I see this picture where you are using a platform and you rate a movie. And because you just rated that movie, like your most recent movie that you rated, you gave it some score. Say you gave it a 5 out of 5. What you can do is you can go find all of the other people that also rated that movie, either the same rating or, we'll just make it simple. Everyone else who also gave that movie a 5-star rating.
Right.
And you want to now crawl every other movie that they also then watched, rated that set of movies 5 stars. And you want to come up with a way to count or rank these movies as the movies that you would recommend now that you have watched something else on your platform. So it's using your friends of your network or those who have also watched this movie to recommend another movie. And
I think we just kind of answered what collaborative filtering is then, because hence the collaboration piece, right? The fact that in this particular rating, it's not just being based off of your own personal likes, but it's the collaboration of those other folks that are in your network that are also highly rating the same types of movies and then filtering based on that, is what I think I just heard.
Okay, yes. That sounds exactly right. And pardon me on the typing. I actually was over here and I just pinged Matthias. I'm like really curious.
Saw you going off as like, Denise is just checking messages. No.
I'm really curious. I'd never heard that story before. And what a fun way to end the live stream if that's like the origin story that we get to find out during this. So anyways, but David, exactly what you said is could be a reason why it's called collaborative filtering.
And Frank just posted something on LinkedIn. I think it's all coming together here. We're in Confluence here. In a more general sense, collaborative filtering is the process of filtering for information or patterns using techniques involving collaboration among multiple agents, viewpoints, data sources, etc. So there you go. Thank you, Frank, for posting that in there. And that, there's actually another little bit of history of this, especially since Daniel Kuppitz is on. The pattern that you were just explaining ended up being, with what we're seeing here in this chapter 10 example, ended up being the pattern that we used in our killer video reference application for the graph recommendation engine.
Yes.
And I have a feeling that had something to do with Daniel Kuppitz, because when we were doing the hackathon for new capabilities, this is years ago now, like I want to say almost 4 years ago or something. One of the teams came up with a graph recommendation engine and had help from Daniel.
That's awesome.
And I wonder how much those paths had crossed, because it was exactly that pattern of, I've got my friends and my friends highly rate something that I also highly rate. So then that brings me over to looking at things that they highly rate, which then gave me recommendations of things I'd probably like because of that, and had no idea that we were using collaborative filtering. How funny.
Yeah. And actually so when you and I have been working with this a while, right? Like we've been doing recommendations and thinking about recommending movies. And everyone on our live stream uses this service if it's going to be on a website or on a social media app.
Right.
You're always going to, here's a connection recommendation. Here's some content we recommend for you. Like we all experience this as a feature in our applications and we just assume there's some magic that makes it happen. So let's actually give a concrete example to what you just said verbally, which is image 10.7. When you have something you highly rate, how do you actually mathematically determine the answer to the question? Like, what's the score going to be? And there's two basic examples that we start with in the book. Well, there's 3, and I'm going to do 2 together with you all here. Okay. This is the first one, and then the second one is going to be the NPS score, which is a lot closer to what you do in a production application. But this first one, David, I believe is exactly what you were just talking about. It's counting the number of ways to basically walk a path when you have a rating that is exactly matches 5. So let's just kind of walk on this image from left to right.
Got it.
And we're going to figure out how A, B, and C ended up getting ranked. A was first at 3, C was second at 2, and B is third at 1. Okay. So on the left, let's say, David, that you just recently watched a movie. Do you have a movie you watched this weekend you want to use this as an example, or you maybe not want to call yourself?
Does it need to be a movie that has a rating of 5?
I mean, a movie that you would rate 5. Unless that's too personal to share.
No, it's not too personal. I have something funny I could say, but not one that I would rate a 5. That was kind of the funny part of it. I'm trying to remember the name of it, but it's failing me. It's one that had Hugh Jackman and Wise. Oh God, it was from so many years ago. She had cancer, and it's almost like this like meditative. I'm trying to remember the name of the movie. It was wonderful. Anyway, I'm not remembering. I'm not remembering. How about the original Star Wars? Like I could watch that a million times.
Perfect.
I have, and I'd say that's a rating 5 to me.
Okay, cool. So then the way that this works is like we can pretend that your streaming service, like this was the first time that you got a chance to watch that movie on that streaming service. Like they didn't have that data before. Yeah. They didn't know. So you watched a Star Wars film and then you rated it a 5. And that's kind of what's happening on the left-hand side of this image. And so once you rate that movie a 5, what you can trigger is a job that's going to update a new recommendation for that window on your app. And what's going to happen is it's going to go and find all other users in their platform that rated Star Wars a 5.
Right.
And so that's the user A, B, and C that we have here in the middle.
So you don't even need to know those users. You don't have to be connected to them. It's just users in the platform.
Yes, exactly. Right. It's just users that also rated this Star Wars film 5. Yep. And then what they're also going to do is for this set of users, we're gonna walk out for all other movies that they rated a 5, and we're gonna grab that set of movies that were also rated 5. Now we're gonna exclude the Star Wars film because we already know that's in the set. We need to find new movies. And so we end up with this list of movies A, B, and C. So the question at this point is like, well, which one is the best recommendation? And that's what this model is saying. It's saying, well, we're gonna count the number of ways that we could end up at movie A, at movie B, or at movie C. So let's just look at C because that's what's highlighted here.
Okay.
User A rated movie C a 5. Okay. And user C rated movie C a 5. So there's 2 ways, or there's 2 paths.
I see.
Yeah, there's 2 paths that we walked from you to Star Wars through this user set to movie C. So we give that one a score of 2.
Got it.
And then you can also see if you follow all of these edges that there's 3 ways to walk up to movie A and only 1 way to walk to movie B. So that's how we're getting the scores. We're counting the paths per se.
I see. And because these paths, though, and let me just make sure I have this right. Since these paths from what I'm seeing, if I go back a step, right, to this, I can't highlight like you can. Oh, that's so sad. Okay. But if I go back, yes, those, exactly. If I go back a step, they're all going to be direct connections, right? From the user to the rating, their 5 rating on a particular movie. So that way I can count up how many of those paths to tell me essentially how many 5 ratings do I have for a particular movie. So it's a good way to do it. It's not like I'm going to have a case where I could have multiple paths, or I should say multiple steps or multiple neighborhoods in a path. It's going to be direct path every time, right? So I know I can count those up. Okay.
Yes, there's going to be direct paths, and by removing that original movie, that's how you're not going to end up with some of those other problems you might be thinking of in your head.
Got it. Okay. So then this way I could simply just count them up, and they're already all highly rated. Any of them would probably be a pretty good recommendation. But let's even bubble it up more by saying, well, out of all the people on the platform, this movie has the most rating 5s. And so that's the one I'm going to recommend.
Exactly. Okay. Exactly. And so that's exactly that. Actually, that's perfect. And I just kind of want to hold it there. So if you're out there and you're listening to this and you're like, man, I really want to figure out how to do that. Absolutely. Dive through the chapter 10 notebook because we take you step by step on how to do this graph walk or how to apply collaborative filtering. And it's bringing together, as you just heard David walk through, 2 concepts that we've done already in this series.
Yep. Neighborhoods
and paths. So you have all the fundamental pieces to apply it together to doing collaborative filtering. You have the chapter 10 data schema and notebook that takes you step by step through it. So now we just want to let you go off on your own and learn how to do this type of collaborative filtering.
Cool.
So let's take it one step further, though, because what I also think is pretty valuable is that sometimes there are people that say that they dislike a certain movie.
Mm-hmm.
So it's not only that you rated it 5, you also want to maybe count in detractors. Yeah, that. Yeah, you might also want to account for those people who gave it a 0 rating or a really low rating. And that's what you start to get into with a little bit fancier math, like doing the NPS or the Net Promoter Score.
Right.
Where you kind of just want to understand across this entire group of people that have watched the movie.
Okay.
I want to know more than just the number of people that gave it a 5. I want to know kind of like the average.
This is like the Rotten Tomatoes view almost.
Yeah, exactly. So if you go to image 10.9, it shows you conceptually the Rotten Tomatoes view or the NPS score, the Net Promoter Score.
You know, it's kind of interesting about the NPS score is that in our, on a little aside here, in our workshops and such, we used to get ratings on NPS scores. I never knew how those were being calculated.
Yes.
Right? But they most definitely take into account detractors and folks that would not be promoters of something. And so it's a more nuanced view on the data.
Right. A loose way to think about it is that your Net Promoter Score is going to be the sum of everything that is a positive rating.
I see.
Minus the sum of everything that's a negative rating.
What are we considering negative in this case? Is it like 2 and down?
In the book, we did 4 and up versus 4 and down. We were pretty strict on ourselves. We said you had to get a 4 or higher in order to be a well-rated movie.
Okay, so even that is pretty strict, because even if it was a quote unquote average score, you're still getting dinged. So you got to really bubble up. Okay.
There is, and so there are entire teams whose sole job is to understand that point.
Yeah.
Their entire job is to understand what their user base defines as good versus meh versus absolutely not. And it turns out that it's a lot more polarized than you would think.
Interesting.
But yeah, so that's what we're doing here in this image. And we walk through everything in detail in the book. So this is definitely a super high level tour. But what you're looking at is the exact same graph from the last example. But just for illustrative purposes, we added in that user B. You can see it here in the center. We added in that user B downvoted user C. Like they actually, which is not often. Usually it's a lot easier, and you'll even see on YouTube, people always are they'll give thumbs up, but it's not often that you actually take the time to downvote something. So what you do, you want to account for it in your models. And the life cycle of how to do this really is getting into the world of data science, but applying it is really easy when you have connected data.
Yeah, so I feel like in the actual traversals, we're going to have some use of SAC and coalesce.
Yes, absolutely.
Okay.
Because you're going to want to be keeping track of the total positive ratings and then subtracting the negative ratings. David, you already know how to do it. So for those of you who are interested in diving into the details of what we do in Chapter 10, this is it. We walk through how to find a user, how to create an aggregate view of that user's rating for the movie, and then do the math of how to come up with a final ranked list here for movie A, B, and C, or whichever movies that you find on your walk.
Very cool. Now, there is a question. Frank in LinkedIn is asking, does the population NPS vary with time?
Yes, it does. Absolutely. And data science teams have a typical 2-step process. Get something up and running. Because, Frank, the problem that you just identified is a real problem, but you don't want to solve for it right off the bat. It's going to be way too much to try and bake in that entire life cycle on your MVP of your recommendation series. So use the data you have, model it in a graph, and follow these walks to get a basic understanding of your recommendations. MVP, get it out the door. Then after that, you're going to likely want to add like a window of the relevance of a recommendation. Because, just because you had a cult following of a movie that was super popular, say 10 years ago, doesn't mean that it needs to be like the top recommended movie now. And especially if you're thinking about how quickly this turns over on Twitter, they're doing the same process in the background. They're having to detect time-based trends and get them in front of their users. And they are applying some of these more time-windowed approaches to recommendations or topic trending, I guess, detection as time is going on, and applying it for more real-time analysis. So yes, Frank, absolutely, that is something that definitely varies with time. So, and I mean, also it varies with the size of your population as well. And we get into that, and that's model 3 on figure 1011, but I don't want to go too deep into it. But if you do show figure 1011, David, there's another aspect to consider, which is the cult following movie, right? When you were looking at these movie databases, movies like Toy Story, or I'm trying to think some of the other.
You're tearing me apart, Lisa.
Toy Story is always something that comes up as a top recommended movie because like everyone watches it and recommends it. Yeah. You also get the Shawshank Redemption in a ton of recommendations because so many users had rated that movie,
regardless of how old that movie is.
Right. So you have the variance with time, but then you also have the variance with population size. So the third model that we show you how to do in the book is how to normalize your recommendations by the total number of people that voted for that movie. So that, and honestly, a production system is going to probably take the top recommendation from all 3 of these models. You're going to run them all in parallel. You're going to get the answer that's like the top ranked from the top 3 from this model, the top 3 from this model, and the top 3 from this one, because you're going to want to see if your users prefer variance or if your users just prefer like the pop culture trending item. That's right. But this model essentially here does the Net Promoter Score, but then you divide the Net Promoter Score by the total number of users that rated it positively, so that you're trying to reduce the signal volume and just get a little bit more information about something that's trending now. And that's actually going to let movie B show up as a more popular choice. So the first example showed movie A, second example kind of down-weighted movie B, and then this third example is up-weighting movie B again. So it depends on what your user base cares about, and you need to consider all of these aspects when you're studying your data.
Got it.
Sorry, that was like a total long rant. Like you kind of got me in my like zone of, oh, this is the really cool stuff about data, and
that's really my job here, right? Is Denise has a plan, and then David comes in and tries to change the plan, right? So I'm glad I'm successful today.
David, you're always successful. Always successful. Okay, so enough of that. Let's talk about what we're going to do in code.
Okay, let's do it.
So image 1014 is going to show you what we're about to go do in code, and then we'll go do this in code. So as I mentioned, this is where you guys are going to go and explore and do your own thing with the rest of the examples in the book. And for the next 10 minutes or so, and again, keep asking questions. We welcome that at any time. For the next 10 minutes or so, I'm going to have David kind of go through and do the templates from the previous examples. And the first one is the neighborhood query. Okay. So Jonathan Ellis, our co-founder and CTO here at Datastax, was very fun in helping us kind of create some examples here. And he's our first person we're going to study. So he's user 134558, and we're going to do a basic neighborhood query, which says, for this user, tell me what movies they recommended. And then we're going to kind of bucket them, David, and say, which movies does Jonathan like? So we'll group them by the edges of like the 4 or higher, and then which one is neutral, and then which one we dislike. All kind of doing those neighborhood queries. Right? Any questions about the neighborhood queries?
No, I was actually responding to something on LinkedIn. No, I'm on the same page. I was actually going to make a quip that I wonder what movies Jonathan would actually rate a 5.
Oh, yeah, actually. And so for the record, I just gave the users from the Movie Lens database random names. So when you're using this data, I did merge in the Movie Lens database. And the fun part about Movie Lens is that it's all anonymous. And then when you're working with this data, you're going to be like, wait, the Practitioner's Guide to Graph Data version has names with these users. I just had a basic Python script, like randomly assign names to people. But then Jonathan Ellis was really, really nice and just let me hard code one of the users. These are absolutely not his real movie recommendations.
Oh, no.
I
thought we were getting some insight into Jonathan right now.
No. So that's the first query. If you go to 1015, that's the second query, because the second query that we learned throughout the series was the trees, right? Mm-hmm. Start at the top and like walk out to the end. Okay. And so we thought it would be very useful to use the Kaggle data that has the actors who collaborated with other actors. And so we wanted to look at the Kevin Bacon tree. And so that's what we did for applying the hierarchical query. We said for Kevin Bacon, find all of his collaborators from 2009 onward. And so this is the Kevin Bacon collaboration tree. And that's another query that we walk through how to do in the notebook. And then the final one is going to be a path-based query. And so that's 1016. And we wanted to say, what's the path between Kevin Bacon and Morgan Freeman?
Right. Okay.
So, tell me if in all of the movies that we have in this database, start at Kevin Bacon, end at Morgan Freeman, and show me all of the different ways that we find collaboration paths between these actors. So,
okay.
Those are all the fun queries that we put together at the beginning of chapter 10 to apply what we've done so far in the series. So let's go dive in and let's look at the gremlin to do these.
All right. So are we in chapter 10 for the notebook?
We are chapter 10 for the notebook.
All right. So that's where I'm at.
Now, a lot of the, for those of you following along in the live stream, a lot of the work that we just went through on defining collaborative filtering and how you started a user and get a ranked list, that work we are leaving as an exercise for you. And it's at the bottom of chapter 10 notebook. What we're going to do here is we're just going to kind of get started with where you always should start when you're playing with graph data. And that is to just get to know your data, walk around it, do the common patterns, which are neighborhoods, trees, and paths. Get to know what's in your data before you go for the higher value question.
Right.
And that's what David we're going to walk through together now.
Okay.
So I think we just really want to jump in, just like every other session. Let's just jump on down to step 3. Query review.
All right.
Yep.
So we should already have our schema in place. And again, for those who happen to be joining us for the first time or anything like that, if you remember when Denise mentioned you could download Datastax Desktop, this whole graph book, everything that we're doing is actually in a Docker image. And through Desktop, or if you do it in Docker yourself, all the initial data in that has been preloaded. So that's why we're not actually executing any of the schema queries and actually creating that. You see that the schema already existed. So that's why we're just skipping right over the part where we create the schema, insert the data, and going right into the neighborhood or going into the gremlin traversals, just in case you weren't aware of that.
Absolutely. Yeah. And so David, I'm gonna let you run this first one. So what we're doing here is we're doing a neighborhood query where we're starting from a certain user.
Okay. Which is Jonathan. That looks like Jonathan.
Which is Jonathan. And we're remembering back to that pattern that we did at the very beginning, like on episode 2 of this series. The pattern of where join select, like the reverse of SQL. Yeah, we're bringing that back. We're going.
I feel like that was like forever ago now, right?
Yeah. Yeah. So the way in my head I see these neighborhood queries, it's like the reverse of SQL. Select from where, and instead we're kind of saying where join select. Right. So the first question that David's going to walk us through is for this user 134558. Show me all of the movies that they rated with the movie's rating, and that's what's happening here. So David, I'm going to have you walk through the gremlin, and I'm here if you get stuck.
Yeah, no worries. Okay, so. First thing, just to point out, is that we are using dev.v instead of g.v, right? Which is important, especially for development. I don't have to worry about any of my indexing or anything yet. But as we've learned throughout the series, this is not what I want to use in production. So this is just an easier way, especially when you're developing and experimenting to get going. So we're first going to, as Denise said, we're going to do the where on the user. So we're going to say where our user is user with this 134558. And just to make sure we're on the same page here in our actual schema, so we're going to be starting on a user vertex because that's what we're asking is we're filtering on a user vertex. So now, okay, we're at that particular user. We're going to walk out all of the rated edges. And we're going to stop on the edge, though. They out E edge in line 2. And you can see here, it might be a little small. I can blow it up a little bit.
Yeah, maybe that'd be helpful. Let's do that. Yeah.
There we go. And you can see that I do have a rated edge. I've rated and tagged edges in this case. So I'm going to walk out all of my rated edges. I'm going to create an alias on those as edges, right? It seems like we're going to use those later. Then I want to get to the movie vertices. Remember, we stopped on the edge because we did out edge because we wanted to store those edges, I'm assuming is why we did that, because we didn't actually pull a property yet. And now we're going to walk to those movie vertices. We're at the edge. We're going to say looking at the direction. We want to then go NV to get to the movie. So this is where we're doing that join, right? We're now joining back to the movie vertices.
You're killing it. This is awesome.
Oh, wonderful, wonderful. And then using project, right? Our favorite step, project, which again I've mentioned before that in code it's actually really nice to use project because it allows you to modify or massage the output into something that something that's going to make sense in code. So from what I'm seeing here, there are three things that I'm really trying to get out of this. I want to get the movie, whatever the rating is, and then the timestamp. And I'm assuming, looking at this, I guess the timestamp to me, I'm looking at what the basic neighborhood query is, and it says show me all movies recommended by this user with the rating. I guess you could do without the timestamp. Yeah. I guess it depends on your particular need and what you're actually trying to do with it, right?
That is a good point. And I love it. There isn't actually like a requirement in this query to return the timestamp. So actually that probably is me being a bad developer. I'm giving something more that my API did not request, but good point.
It depends on the use case. So so really what I'm trying to get out of this though is I want to get the movie, the rating, and the timestamp. So then using the pattern project by, moving down to the next one. And again, the by modulators are going to be applied to each of the values, so movie, rating, and timestamp in order. So this first one, I'm going to say, okay, well, I'm at movie, and what I want to do is I now want to get the movie title by using the movie title property, I should say. So if I click on movie, I should have a movie title column here, which I do. So there's that property. Then I'm going to say by select edges. So I'm going to go, I'm still, as I understand it, now I want to get that rating, right? Now, what's really neat here, this is a little bit different what I actually expected. We used the alias edges before.
Yep.
So now I'm going to reselect edges and grab the value that was in the rating property that was actually in the rated edge.
Yep.
Right. So if I take a look at that here, I should have a rating property, and I do. Wonderful. And then I'm going to use edges as well. I'm going to do the same thing and get the timestamp property. So again, if I click on this, I open it up, I should see that I also have a timestamp, right? So I'm able, it's actually really neat too, especially now in this version where we have CQL under the hood, and you're able to make that direct connection to it. It's really nice as far as I'm concerned. So anyway, so that's it. So then, all of that comes together where we get the movie, the rating, and timestamp for each one of these based off of our original user 134558.
Boom! That was it. I love getting to walk through these again and hear the way that you think through the traversal, because I feel like multiple perspectives on how these queries work is so valuable. So that was absolutely it. And then to your point about building up the JSON object, you can see it here on the lower left, right? Like the keys that you were talking about on line 5?
Yes.
Yeah. So you still have all the data and the associated keys from the map, movie, rating, timestamp, and then the appropriately populated values. So that was great. David, do you have any other thoughts on this first query?
No, not yet. No, it seems pretty straightforward, honestly.
Yeah, and Daniel, I love it. Nitpicker alert. It's okay. This is something that we can always submit as a bug in the text, and I can fix on the online version if you guys would like. But typically for those graph practitioners who are very experienced, like Daniel, the label that I use on line 3. It's just one edge. Yes. So he's saying this is not a collection. Yes. It should be like just edge. Great point, because it's only really one user and like that one rating over to a movie, because it's only the edge of the current path. So
that's right. Yeah.
But at the same time,
I could see it from a human readable standpoint. I could see why somebody would label it edges.
Yeah.
But that's not technically correct, because it's not a collection of edges.
But but it's okay. But no worries. Cool. Yeah, Daniel, totally right. Thank you for that. So what we can do now is what I think is kind of fun to do with this this neighborhood query is to is because I think at first you were like, oh, we're probably going to use Coalesce. And that's where we go next, right? Because let's bucket these recommendations according to those that are liked, those that are neutral, and those that are disliked. And that'll be the last query that we do for this, because I'm kind of looking at the time, and I want to make sure we leave time for anyone to like ask questions, and we can wrap up our series. So let's make that be our last query, and that should be the next one, where we want to bucket.
Yeah. What do you know?
Bucket them together.
What do you know? You were totally correct. Why am I not surprised?
I mean, I'm cheating. I have the book pulled up next to me.
Well, you kind of, wrote a lot of it too. So there, it does help when you actually are familiar with the material.
Yeah, but usually when you are when you're working with your data science team, right? So like this example is like right in the middle of working with the data science team and then your production machine learning engineers to apply this type of example in prod. You don't want to get as nitty gritty to what the actual exact rating is. You usually just want to deal with buckets. So that's what we have. We've defined this bucket that liked is going to be the ratings that are what, greater than 4.5?
Yes. Yes. And
then can you, it's hard for me to read your screen just because of the way our setup is. So what are the neutral and disliked ranges?
Neutral is 3 to 4.5.
Yep.
And then disliked is 0 to 3.
Yep. Okay, perfect. So we're gonna do that exact same thing that you just did, but instead of displaying the results of Jonathan Ellis's ratings, like give me the movie and the rating and when he rated it, let's just make massive groups for every movie he's ever rated.
Right.
And let's look at those that are neutral, those that are positive, or those that are liked and those that are disliked. And so we're gonna set up this query exactly like how you just did in the last query, David. But the new step is on line 3.
Okay. Yep.
So we start at the user on line 1, and then we have all of our traversers go out onto the edges of rated. Right. So in my mind, like I see all of these gremlins now hanging out on these rated edges. And then they're like, well, what do we do now? And on line 3, we say, all right, we want to group you all. And we're going to group you all into 3 different groups.
Now, to be clear, though, by saying group into 3 different groups, there's nothing in group itself that is specifying it's 3 groups. It's because we're grouping by the rating values and what those are going to come out. That's what's defining in this case, because what we're doing in the Coalesce, there's only 3 values that you can group into.
Exactly.
Okay.
Perfect.
Okay.
Perfect. So that was brilliant, David. And the group step makes a map.
Okay.
And so then you have to say, well, what are the keys in my map and what are the values in my map?
Cool. Oh, okay. So so in group, you should have 2 bimodulator. Your keys, your values.
Yep. There you go.
Okay.
Absolutely. And so the bimodulator that spans line 4, 5, 6, and 7 is going to either be, if you liked, it's going to be the liked key. Yeah, there you perfect. The liked key, the neutral key, or the disliked key. So I'm thinking I want my map to say liked and then all of the movies titles that they liked. And then I want to say neutral and then all of the movie titles that were neutral. And so that's what we're doing here on 4 to 7. We're setting up the keys. And the way that we have to kind of create those keys is according to the actual rating. So in your head, your gremlin is hanging out on the edge. Mm-hmm. And we say, hey, on line 4, I want you to tell me what your rating is. And that's what we're saying. Get the value for rating on line 4.
Right.
And then 5, 6, and 7 is kind of like a if then or a choose statement, if you will. Yeah. So do you want to take it from here on what's happening on 5, 6, and 7?
Well, yeah. So, and honestly, I think you kind of just explained it. But here, our Coalesce, if we do treat this like an if then else statement, right? We're first saying, okay, so again, we're hanging out on that rated edge. We're getting the value of rating, which is a property of the rated edge. Mm-hmm. Those ratings are going to be, the numbers that we see here, like from 0 to 5. And so we're essentially defining. I like what you do with constants, by the way. I see that. So if the rating is 4.5 or greater than 4.5, then we're going to essentially give it a constant of liked. Mm-hmm. If it's greater than 3, now that's interesting. I guess, okay, so this is, I find this interesting because I'm not having to put the full between range, right? I don't have to say if 3 to 4.5.
Correct.
But I believe it's because of the way the coalesce works.
The ordering. So like,
yes,
it's first going to check, are you 4.5 or greater?
Yes.
And if you are, you go into the liked bucket.
Boom. You're not going to, right. It's not. So then if that occurs, I'm not evaluating the rest of them. I don't need to.
Exactly. I
get it. So you're making an assumption that if you've gotten past the ordering of liked at 4.5 or greater, then you're obviously lower than that because you would have filtered out on it. So then that's a nice little optimization. Now, just a weird question. You could effectively go and do it in the like between route, couldn't you?
You could.
But it's not probably the most efficient path to do it.
I think it's just a stylistic. Okay. I think honestly, for efficiency, we would have to know what's the most popular rating bucket and have that one be first.
Okay.
I think this this ordering is for mathematical accuracy. Okay. Because I'm not doing, because I'm not checking the endpoints. I'm using the logic flow as my endpoint, but we're getting really in the weeds there.
Yeah.
But basically, because it executes these in order, if you pass the first one, you're gonna be in the liked bucket. But if you don't pass 4.5 or greater, that means you're lower. Yep. And so we want to check 3.0 next. And if you fail that one, then that means you're under, and you go into the disliked category.
Right.
Yeah. So it's not necessarily an optimization, just more like a way to organize your statements so that it's mathematically accurate.
Okay. Yeah. So again, in the coalesce itself, we only have one of three options. I think the filters here, you can see it. Is it greater than 4.5? Is it greater than 3? And again, if it's in the 4.5 or greater than realm, you'll never get to this, right? You have already exited here.
Exactly.
And same thing here, right? So then that is going to, then those are going to be our keys, what we're going to group by our keys. And then this last one here, again, if we're sitting at that edge, the rated edge, then just like we did earlier, right? Well, if we want to get the movie title, we're going to need to traverse to the movie. So that's what we're doing at the NV, grab the property of the movie title. Now, I find it interesting that we're folding here. I assume that means it depends. I have a feeling that there's more that would be returned here in what we'd see in the actual output, which is why we're folding. I kind of want to take the fold off and run it and see what it looks like.
Okay. Yeah, why not?
Let's
go
just
ahead.
See real quick. Oh. He was trying to help me.
I mean, I am all for changing these queries and seeing what happens when you run them.
That's right. It's only going to return. That's right. That is something we did. We did that in like one of the first chapters, didn't we? Where you could kind of get tricked, right? If you have an array of items and you don't fold, you're going to see like the first one, but you need to fold in order to see the whole set.
Exactly.
Okay.
Exactly. So let's do that again, but actually run the query. Because you did all that in your mind, but we stopped on the results.
I did it, but I moved away really fast.
Yeah. So we just
I saw it and was like, duh. Yeah.
No, but it's awesome. It's not a duh moment. It's synthesizing concepts we did from the beginning, which is why I love this chapter. So what do you see here in the results that made you go, oh yeah?
Well, I only saw a single item for each of the categories. And unless our user here only happened to rate 3 movies that very neatly fit into every one of the different groups, which could be the case if it just happened to be a very small data set. I just didn't believe that was actually the case. I knew the output was different, right? But then it dawned on me. I'm like, wait a minute. I'm not seeing the whole array in each of these cases, right? So that's what I kind of wondered. I was actually thinking about fold the opposite way.
Okay.
So I originally had it incorrect, but I knew that I needed it.
Yes. And so for those of you following along, I think David put fold back in the query, but when you...
I just did, yeah.
Okay, cool. When you remove fold, you're going to get the first answer. And so you're going to end up really with only 3 traversals, and then your query is going to return. So you have to think about functional programming. This is thinking more in streams where you're getting the first answer so that you're making the most responsive API. instead of getting all of the answers. So there's a big difference there. And that's what fold is doing. Fold is a barrier stepping gremlin. And barrier step essentially say, hold on, wait until everyone finishes before you return your results. Before you return your results. So that's what's happening with fold. You're saying, hold on, I want to get every neutral movie, every liked movie, and every disliked movie before we return the full payload back, back into this, and before we return the full payload. So that was awesome. I'm really glad that we did that. That was a really great way to kind of go back and remember fold. So, yeah.
Yay.
Cool. Well, that's the last example that I think I want to do here. There's a ton more. We go through and we do tree queries, we do path queries, and then we dig into all of the recommendation queries, which I think we kind of start digging in and maybe doing Lion King recommendations. I forget which one that we did towards the end of the notebook. But
we have a recommendation example. We have NPS score. Oh, wow, there's a lot in here. Normalize NPS.
This is a huge notebook. There's tons. Like, we could spend like 4 series of episodes just doing what's in chapter 10. But cool. the whole premise, and I'm waiting for questions up here on LinkedIn or YouTube. Like, we'll take questions at any time. But the whole premise of chapter 10 is to teach you the basics of how people do this analytically, because you're going to have your data science team running these longer running queries across all 20 million recommendations, or across the million new recommendations you just got the past day, and to update the data that you want to show in the actual recommendation window. That's not going to be done on click, right? So like we are bound by time and space on being able to run that large of a mathematical computation actually in app when you're using Netflix or using whatever recommendation service. So what you're going to have is you're going to have an analytics center or an analytics database or some type of environment that your data science team is going to be refining their models, or that in production they're doing a model update or a model refresh, and then it's going to send over new data that needs to be queried in production so that your APIs have a 5 to 10 millisecond SLA. Otherwise, your users are going to get mad that your recommendation isn't responsive. So we go through all of that in detail in chapters 10 and 12. If you're curious about entity resolution and how to match and merge data sets together, when you use a graph, when you don't, that's what we do in chapter 11, but it's kind of a sidebar from the different topics. So that's why we're not mentioning it right here on the live.
So it sounds like you could open up chapters or notebooks 10 and 12 if you don't want all the story and you just want to know what the resolution to it is, right? And you want the punchline. But if you want the backstory and you want to understand why and where the stuff comes into play, then it's good to go through the initial chapters, I should say.
Yeah.
Because it's funny. I don't think with some of the things that you pointed out, I would have given the same answers if we had not stepped through these. If I just saw them, I'd be like, well, why did we do that? Or where did that come from? And it was going through all the initial chapters that really made the difference there.
Oh, wow. Okay, awesome. Well, I'm really glad. That means that this is coming together in a good way.
Yeah, I would agree with that. I would agree. So we've got 2 minutes. So I take it at this point, we're done with the traversals. And that's it from that standpoint. Where that's our last traversal.
Yes, that's last. And I'm curious to maybe put you on the spot, David. Throughout all the traversals that we've done, is there a pattern, like a template pattern that we've done throughout this series that you were like, oh, I didn't know about that before, and that's super valuable for the next time I go to write a graph query?
Well, funny enough, from the recommendation standpoint, this isn't actually answering your question, but from the recommendation standpoint, I'm actually really happy to see some of the stuff I've seen in place here and what you were just explaining, because it's extremely similar to what we ended up doing in Killer Video. And yes, a lot of that did come from some of the same folks that probably influenced this content as well. But it was nice to see that the end result wasn't actually that far off, but there are definitely some optimizations there. I think for me, one of the most aha moments I had was when we were in the repeat loop with a limit 1 when we wanted to get the simplest path. I think that was really neat because that's definitely something that, working with paths and such in the past, that just, after you pointed out why, I was like, oh, wow, that seems so simple, but it just wasn't something that was that obvious.
That's so
right?
cool. I'm so glad you know that, or that you said that as an example. And for those of you who are curious, I think that was the episode before this or 2 episodes ago. And like one of the most powerful questions to use a graph database for is to tell me how 2 pieces of data are connected when you don't know how they're connected. And the boilerplate template for doing that in Gremlin is what, 4 lines of code?
Yeah.
It's 3, no 4. It's 4 lines of code. So we walked through that in a previous episode, and David, I'm so glad to hear that that was one of your favorite takeaways. So,
by the way, just Daniel comment says, got to hop into a meeting. No time for an AMA, unfortunately. Anyway, I just wanted to say, great show. Keep it coming. Maybe make a whole show around one specific use case.
Yeah, we could do that. Like if we took the movie recommendations as an example and just did a full series end to end on how we came up with this, I think that would be a potential. We could definitely dig into that for a very long time for sure. So, well, Daniel, thank you so much. I was so grateful to have you here the past few weeks. Enjoy your meeting today. And I think Frank had mentioned, I was waiting to see if Frank, he said he had 3 questions, but I haven't seen him pop up and we're pretty much out of time. So you guys, David, thank you so much for doing this. And just hopping in and taking a dive through all of this content that we created in the Practitioner's Guide to Graph Data. I had a blast. I have loved getting to do this with you, but we have more stuff that we are cooking up here at Datastax. I don't know how much I've told you about that, but there's definitely more shows that we could be doing soon in the future.
So what I'm hearing is, even though this is the final episode of what we're doing today, with the Graph Data and Code show, that don't tune out, right? We have more coming. I actually don't know what all of it is, but Denise says we have stuff coming, right? So, so are you thinking that things may kind of be at the same time and place kind of deal, or just kind of stay tuned on our channels and we will say something?
How about you guys tell us? Here's what's happening. I'm back to building. So we've got a fun team here at Datastax, and we're building some new apps and some new examples. And so we're going to have another show coming out where we live code and show you all how to build this app end to end. It's going to be super fun. Think distributed apples to apples, or Cards Against Humanity, depending on which flavor that you like.
I like Cards Against Humanity.
But no, so I'm back to the keyboard. We're building new stuff, and we're going to have more shows in the future of doing live code and live building of applications. So if you guys have opinions on what time you'd like that show to be, or what you want to see done in that show, let us know. I can tell you right now that the stack that I'm writing in is React and Redux, and kind of building that full stack end-to-end example with our new APIs that were coming out in our products. So lots more building coming from us in the future.
Excellent. Well, with that, we are over time. So it's time to close it out. Thank you, everybody, for joining us on this fun journey as we went through all of the different chapters and notebooks. Don't forget that you can do this too, right? It's all for free. It's out there for you to go through all the material. And what's the coolest part about it too is if you are exploring any of these types of use cases, you kind of have the answers here. I mean, you have to modify things obviously for your own data set and for your own needs, but the traversals themselves and the use cases that are explored in them are sound. Right. And there's a lot of really cool new tools like the dev.v and such that you can use, especially for development. So take a look. Thank you, everybody, for being with us. And thank you, Denise. This was fun for me, too, by the way. It was actually really neat kind of going at it where we, purposely did not practice this stuff beforehand. It was just like raw, like, let's do it and get into it. It was kind of a fun little experiment. So I look forward to seeing what we're going to do again in the future. And with that, everyone, take care. And we are always on LinkedIn, out in social media. Feel free to reach out. Frank, we saw your questions, but we're going to have to follow up after. All right, everyone, see ya. Take care.
Bye, everybody.